Okay.
Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. Do 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 science. You're done?
Done. Hey guys, hope you're still doing well. Today I'm going to be going over your specific heat stuff. Hopefully everything's been going really well for you. I've been hearing from a lot of you, some of you that I hadn't heard from since we all went to this distance learning model. I've started to hear from, so I'm really excited about that. I want to show you guys the calendar real quick. I've made some changes to the calendar. What you'll notice is now on every Wednesday I have in there, it says Wellness Day. So again, you should be able to see this live update that I've done here. But what this means is that on these days, I will specifically be available for you guys to ask questions, but it will not be a day that I'll be assigning any new homework. So if you take a look, this is what our month of May now looks like. It spaced things out a little bit for us. We are trying to squeeze in 2 more tests. We're just about done with your heat unit, so we should be finishing that up soon. And then you have a waves unit that we're going to try and squish in here before the school year's out. So waves will be our last unit. You will notice that I have left June open. I usually do a school-wide competition at that point in the year. However, with things as crazy as they've been, I think I'm just going to leave those open. Try and stay on schedule with all of this. Ideally, you guys are getting things done the same week that they're being assigned, but I know how life works. So the only thing that's absolutely set in stone are those tests. Make sure you're getting those to me on the day that they're on Schoology. Other than that, what we're doing today is specific heat. So to show you the assignment that was shared with you, your specific heat assignment looks like this. I know you guys aren't my chemistry students, but you will see this again in chemistry. What you guys need to know is that Q stands for energy, and it will be labeled in joules. Specific heat is, its variable is a lowercase c, and that will be labeled in joules per kilogram times Kelvin. Your mass is going to be in kilograms, and then that delta T stands for change in temperature, and all of our temperatures are going to be converted to Kelvin. So your last YouTube video was about temperature conversions. We dealt with Fahrenheit, Kelvin, and Celsius. In this one, you will only be dealing with Celsius and Kelvin, I believe. And some of them, Celsius and Kelvin. So I threw out Fahrenheit. We will only be working with Celsius to Kelvin. To convert from Celsius to Kelvin is just to simply add 273. So that one should be pretty easy. I'm going to show you guys an example. Again, this is directly off your homework. I'm just going to do question 1 with you. So, cute cat meow. Those of you that are a fan of my triangles, I will triangulify this equation for you. My Goofy's back. Okay, so if energy is equal to these guys, that means that we would have a 4-variable triangle. And the bottom doesn't necessarily matter what order you put these guys in. It's just the fact that these variables belong on the bottom. I'm just trying to think here, and our energy will go on top. So Q stands for energy, and that will be labeled in joules. Then we have our C, which is specific heat. Oops. Specific heat. Cool. And that will be labeled in joules per kilogram times Kelvin. Then you have your mass in kilograms and your change in temperature in Kelvin. And that's change in temp. So that is what your triangle would look like. Just to backtrack a little bit, what specific heat is how much energy is required to raise the temperature of a substance by 1 degree Celsius. What that means is it's telling you how much energy is required to heat up a substance. So if you look back at your homework, I have a table, and I'll just flip over here real quick. You have a table that tells you different substances. So I've got everything from water to aluminum and carbon, and they tell you what their specific heat is. This would be given to you in joules. So this is how much energy is required to heat up each of these substances by 1 degree Celsius. So it's kind of a confusing table because we've got one set of substances and specific heats over on the left, and then on the right we have another set of substances and specific heats. But what I want you to notice is that a lot of these are going to be metals, and metals don't take very much energy to heat up. So if you're looking at like lead or iron, even gold, they don't take a lot of energy to heat up, and that should make sense. That should be something that resonates with you. You could say, oh yeah, I've made s'mores before, and that hot poker gets really, really hot, and you want to have that wood handle in good condition, otherwise you've just burnt your hand. It's because it doesn't take that much energy to heat that metal up. On the other hand, substances like water take a lot of energy to heat up. When you have to make mac and cheese and you set the pot of water on the stove, it takes forever to boil. So that's what you're dealing with there. So again, just to give you an idea of what specific heat is and what you will be calculating. But if we're doing question 1, it says when a metallic substance, hint, hint, with a mass of 1.32 kilograms absorbs 3,250 joules of energy, the temperature of the metal increases from 273 Kelvin to 292 Kelvin. What could this metal be? What we're going to be doing here is it doesn't necessarily ask for part of our triangle. And so what we're going to be solving for is kind of how to figure out what we're solving for is kind of backwards from what we would normally do, because what could this metal be is not a variable in our triangle. And so we're going to figure out what information they do give us to figure out what it is we're looking for. And then we're going to use this chart to get our final answer. So just to fill out the triangle here for you, let me go back over to my paper. Old school likes to do things this way, and I like it too. So I'm going to make a big triangle here. And we've got energy, specific heat, mass, and delta T. I'm going to fill out each of these where I would find them. There we go. From the word problem. So I'll fill out my triangle as I go through. It says that we have a metallic substance with a mass of 1.32 kilograms. And if I check my unit for mass, it needs to be in kilograms, and it's in kilograms. So I don't have to do anything else for that box. Cool. Then it says that it absorbs 3,250 joules of energy. That's going to go up here. 3,250 joules. And again, if I check, my energy should be in joules. Awesome opossum, that's where it's at. We don't need to do any conversions there. And then it says that the temperature of the metal increased from 273 Kelvin to 292 Kelvin. And if I look up here, it says change in temperature. Change in temperature is going to be one number. What we were given was a range. And so what we need to do is we need to subtract these two values to figure out what the change actually was. So if you can see on my calculator, I'm going to take my 292 and I'm going to subtract my starting point of 273, which gives me a delta T of 19 Kelvin. So even though the equation never said what is the specific heat, it asked what was the substance, we now know that we're solving for specific heat because they didn't give us any information about it. So the first thing we'll do is cover that up, and we're now looking at our equation. Everything on the bottom of the triangle needs to be multiplied, and then we will divide the top of the triangle by the bottom. So in this case, I'm going to take 1.32 and multiply it by 19. Whatever that value is will be my denominator, and then I will take this as my numerator and divide it by whatever my denominator value was. Once we divide those out, that will be our specific heat. So just to do that real quick for you. So we get a value of 129.59, and again I'm rounding to the nearest hundredth on this one, and my label for specific heat is kind of crazy. It's joules per kilogram times Kelvin. However, if you look back at the question, it is not asking for a specific heat, it's asking for a substance. So I have this value of 129.59, but if I look at my chart, I'm now wanting to find as close to that value as I can. And if I look, there are two different possibilities. My first is lead, which has a value of 129, and my second is gold, which has also a value of 129. So for number one, an appropriate answer would be either gold or lead. If you had one or the other, I'm not going to get bent out of shape over it. But that is how you're going to use your chart to answer these. So you're doing some math, you're using the chart. Sometimes if you're like, hey, it didn't give me enough information, I guarantee it told you what the substance was, and then you'll use this chart to figure out what the specific heat is. So keep that in mind. For example, I'll just tell you which one it is. When you get to number 4, it tells you that you're dealing with silver, but nowhere else does it talk about the specific heat of silver. You're going to need to use this chart to look up the specific heat of silver and use that information in your equation. So I hope that helps. I hope the new calendar makes sense, and you guys enjoy your wellness days. Make sure that you're getting what you need. And as always, if you guys have any questions for me, please email me. I'm here, ready to answer your questions. Enjoy! Over here, I call this my QCat meow equation. Forget Fahrenheit. We don't deal with him anymore. If you put these variables in the right order, cat, look at me, because when you're talking about QCats, maybe they meow.